mass and energy balance. In any system, when you're producing a product, you must know what is coming inside the system and what is coming out of the system, right? That is why now we have this mass and energy balance. So mass and energy balance, it's a fundamental concept in engineering used to analyze the flow of materials, right? The inputs the input and the energy within a system. This is important as it helps us in knowing the mass and energy that has entered, the transformation that has happened, and the exiting. Here is where we have the final product. So this encompasses all this, what is coming inside the system and what is coming outside. So for that to happen, we have to have system boundaries. So system boundaries, it defines the limit of the system being analyzed in a mass and energy balance. Let's say you're producing, what can I use as an example? Let's say you're producing soap. You have to have those system boundaries, something that is encompassing the. Let me give you an example. We have the physical boundaries, like distillation column. Let's say we are making, let me use a diagram, or vessels. Let's say pipes, vessels. So this is the input. This is the raw material that has come inside the system, right? Let's say it's like this. It undergoes boiling. So under the system boundaries, the first system we have is the physical boundaries. For example, the vessels, right? So whatever materials is coming in is set, and it is limited by this physical constraint. You understand? Yes. And such include chemical reactors, the reactor vessels, like this one. For example, when you go to Kengen in the production of electricity, they have those pipes that transport the steam. Right? That is the best example I can give. So that system itself, it acts as a physical boundary. The second is conceptual boundaries. Conceptual boundaries, these are the concepts that are put in place by the engineers conceptually. These are the systems that are put by the engineers to make sure that productivity occurs smoothly. And these include frameworks, time frameworks, layout. For example, how the machine are going to be set, that is a type of conceptual system boundary. The third is a time boundary. In any production process, we must know how long that production is going to take place, so that we can save on cost and for the purpose of budget. For those big companies that manufacture goods and they are receiving, let's say, funding, they're usually told to make a time frame, so that when that time frame passes, budgeting is going to be limited. So that is the third boundary. The second part is input and output streams. In any production of goods, we have the input, what is coming inside, and some of those inputs are raw materials. You can give me an example of a raw material for production of, what can you say, production of, what example can we use?
Production of,
let's say production of electricity, right? So the raw materials are going to be something like steel. So that is raw materials. What is coming inside to produce that product? Then we also have recycled streams. Recycled streams. There are some production process whereby the materials, once they are not fully used, but they are recycled, they are injected back into the system. That is the recycled streams. Then we have utilities. In any production of a material, we usually have things that are being consumed. For example, water. Actually, this is the most important utility. Even when you are producing clothes or fabric, water is the key utility. We have also energy, for example, electricity. Yeah. Of late, you've been hearing companies are shutting down because of the high electricity tariffs, because it's one of the main inputs in any production. Then we have feed streams. Feed streams are any material that supplies the process, e.g. fuel and combustion. Fuel and combustion of engine. Something that